morning. Welcome back. So we're going to be continuing to graph linear equations. Yesterday when we graphed them, we did it off of the table, and we had a bunch of points that then we plotted, and then we drew the line through them. Today, we're going to plot them off of the straight equation. Okay? So let's talk about the different equation types that we see. I want to start with this one. This equation type is known as the slope-intercept form of a line. It's called slope-intercept because it has the form y equals mx plus b, where m is your slope and b is your intercept. I will be doing a little bit of highlighting, so if you want to take a moment to pull out some highlighters, that would be okay with me. Okay. So let's look at more slope-intercepts. The next one just under that is also a slope-intercept. And then at the very bottom of the page, the lowest right-hand one is also a slope-intercept. So on the right-hand side, the bottommost item is also slope-intercept. All right, let's figure out how to graph the slope-intercept. As noted before, you're given information on the slope, and you're given information on the y-intercept. So here, my slope is 3 over 4, and my y-intercept is given to me as 0, negative 5. So I'm going to graph the y-intercept first, and then I'm going to use the slope to count my way to one other point on the line that then I can use a straight edge to draw my line through. So 0, 5, 1, 2, 3, 4, and 5. And now my slope. My slope is 3 over 4. So I can go up 3 and to the right 4. Or I could go down 3 and to the left 4. I could go in either direction and I'll still end up on the line. Okay? And that's because positive 3 over 4 can be written and thought of as negative 3, negative 4. Okay? And so that's what allows you to go in either direction. Okay? Just go wherever you have room for and whichever is comfortable. Okay? So I'm going to go up and to the right. 1, 2, 3. 1, 2, 3, 4. And the next point on my line I expect to be right there. And then I'm going to take my straight edge and I'm going to connect the dots. And I'm going to write out that this is the function f of x equals negative 3 over 4. Oh, I'm sorry, positive 3 over 4. 3 over 4x minus 5. I just copied this down. It's really hard to read, but it's this. It's supposed to be this. So that mess. This mess is this right here. Just, I'm trying to label my line, that's all. Easy enough? Do you want to see another example of this one? Yes, okay. I have 2 examples of slope-intercept on the left-hand side of the paper. The top one or the bottom one?
Bottom.
The bottom one. Okay, so I'm going to slide over to the left side. The example in the middle is my slope-intercept. Remember that the slope-intercept form of a line gives you information about the slope and the intercept. So my slope is negative 2 over 3. And again, since I've got a negative, I can go down and to the right, or I can go up and to the left. My y-intercept is 0, 1. I'm going to graph starting with the intercept. Start here. I'm going to graph the intercept, and then I'm going to use my slope to get to another point. So I'm going to go down 2 to the right 3. 1, 2, to the right 3. 1, 2, 3. There's my next point, and now I can use my straight edge to connect the points. It looks like I missed one of the points, but sorry. Yes? All right, did you want to see one more example, or is that enough? That's enough for some. That's enough. Gentleman over here. Is that enough, or do you want to see one more? One more? That's good? And then on this side of the room? We're good. We're good? Okay. And of course, I'll be around after this, and if you want me to run another one with you individually, I'm happy to do that. Okay. Related to slope intercept is going to be this one, which is called point slope. Point slope is called that because here is your recipe for creating this type of equation, and it gives you information about a point, and it gives you information about the slope. Okay. Your point is x1 comma y1, or in this case 4 comma 2. Notice how the subtraction sign is part of the formula itself. And so if that formula has a minus sign there, you're going to look at this sign and you're going to take the opposite of whatever that says. So because my formula had a negative here, and this has a negative here, my x-coordinate is actually a positive. A negative and a negative make a positive. Yes? Okay, I guess not. Does that make sense, the negative and the negative? Yes? Okay, because that was always the hard part for me. All right, so we're going to start at this point. We're going to graph that point much like we did the intercept, and then we're going to use the slope information in order to do rise over run. And I rewrote the slope from the integer 3 to the rational number 3 over 1 so that I can easily see my rise and my run. Okay? You don't need to do this if you can think it. Okay? All right, so going to start with, this one is that graph. All right, so we're going to start at 4, 2. 1, 2, 3, 4, 1, 2. And then we're going to go up 3 to the right 1. From that point that I graphed. From this point. 1, 2, 3, 1. Okay. And now I'm going to take my straight edge and I'm going to trace my line. This is this line right here. Y minus 2 equals 3x minus 4. Not terrible? Exact same skill, you just have to go through reading the point off of the equation, and that can be a little tricky, I'll grant you. Questions on this one? All right. Let's look then at the standard form of the equation of the line, and that's the last two examples that are left on our paper. So this is standard form. It's called standard form because x and y are hanging out on the same side of the equal sign, and I have no rational numbers. I only have integers. So a, b, and c have to be integers. Yes? It's ax. So, sorry, my bad handwriting. Ax plus by equals c, where those capital letters a, b, and c have to be part of the integer group. Okay, so no fractions, no decimals allowed in standard form. We have two methods for graphing it. Method number one is going to use intercepts. And method number two is going to convert this equation to slope-intercept form. And then it becomes a slope-intercept thing, and you know that process. So let's talk the intercepts first. In order to use the intercepts, we basically have to solve this equation twice. We have to solve the equation once when x is listed as 0, and when we're done, we'll get a value for y. And then we're going to go through and do it again, but this time we're going to make y 0, and we're going to solve it and get some sort of value for x. And then these points will become the coordinates of the 2 points I'm going to graph on my coordinate plane that then I'm going to connect with a straight line. Okay? So let's do that right now. We're going to take this equation up here, this one right here, and I'm going to substitute a 0 in everywhere I see an x. And now I'm going to solve this for y. Questions on the algebra? Do you have to start with 0? If you're using the intercepts, yes, you have to use 0, but generally you don't have to pick 0 if you don't want to pick 0. Picking any value for these will work. We just like 0 because notice how easy it makes the algebra. It makes it so that way it's literally just the other variable equals the, you know? Whereas if you pick something else, you're going to have something here that then you're going to have to subtract or add, and then you're going to have to, you could get a weird fraction, and yeah. The intercepts are usually safer in terms of cranking the algebra machine. All right, we're going to do the same thing over here with the y's. Feel free to skip as many steps in here as you need. You only need to write down what you need to write down to know what you're doing. I tend to show more work so that way you can keep track of what I'm doing.
Oh, so only like for the x, you substitute a 0 for the x.
Yes.
And for the y, it's
Yes. So we had to do it twice. And now that you have these 2 points, graph these 2 points and then connect them with a line. I'm doing the graphing off screen right now because I know some of you might still be copying method 1 stuff. And so I'll reveal what I graphed here in a second. All right, there's what I graphed. Let's talk method 2. Method 2, I said convert it to slope-intercept form and then just do the slope-intercept thing to it. So I'm going to take my standard form of the equation of the line that looks like this, and I'm going to rewrite it so that it ends up looking like that. Which means I want y by itself, everything else on the other side of the equal sign. Got a few people with phones. Can I get you to put those up for now, please? Thank you very much. And now this looks like all the rest of the slope-intercept things that I had done. Where you have an intercept, and you have a slope, graph at the intercept, and then count up and to the side, or down, down into the other side, or whatever form you need in order to get the slope. Yes? All right. There's one more standard form of a line. Did you want to see that one run? Nope, nope, nope. All right, feeling really good with that? All right, that's all I had today. Thank you.